Okay, today what we're going to do is we're going to finish off this first half of the unit. We're going to look at quadratic word problems. So we're going to look at scenarios where you get some sort of word problem and we're going to use a quadratic equation to help us solve it or find missing values. So here's an example of one. They give you the equation of the quadratic. So this is a ball being thrown up in a parabola shape. So you can see it's a quadratic shape. And from that equation, once we know the equation, we can find the maximum, the x-intercepts, y-intercepts, anything like that. So there's basically three types of questions that you generally have to work with. The first one is the easiest, and that's like what we just looked at, where they give us the equation. So they're going to give you the equation. The only thing that's going to be different is it won't be given to you as y equals. So you might get a formula, something like height, with time as being our variable, and it might be something like 4.9 t squared plus 3t minus 2, or something like that. So what that means is our equation, if you're going to put this on your calculator, we would use x's and y's instead of t's and h's. Okay, but other than that, it's the same thing. So all you got to do is switch it to x's and y's, and then just remember what you're using. So later on, if I'm asking for a height at any particular time, we're looking for the y value. If I ask for something that's time, we're going to be looking for the x value. That's about the only thing you got to be careful of. Okay, so here's our first example. So we got a football that's being thrown up in the air. So they get our equation. So they give you the equation. So what we want to do is type that in now as y equals. So on your calculator, put in negative 4.9 x squared and then plus 5x. Oops, I'm having trouble with my calculator. Okay, so put that in your calculator, graph it. We end up getting a graph that looks something like that. So you can see we've got a few different things going on. So now let's answer our question. So the first question is saying, what's the height of the ball when t equals 1? So on our calculator, we can figure out any height by using value. So if we go second calc value, we can put in an x of 1 for our time, and your calculator should give you whatever the corresponding height is, which is 2.1. So 2.1 meters would be our correct answer. Next question, what's the maximum height? So we're looking for the maximum. So on your calculator again, go second calc max. And you're going to have to go left and right of the peak. So do that. Hit enter. And it gives us a coordinate of 0.51, and then the y coordinate is 3.28 if we round it off. So this question is asking for a maximum height. So what we're looking for is what's our maximum y distance, so that would be the 3.28 meters. The next question on here, it says when does the ball reach the maximum height? So that would be our time value of the maximum, which is our x coordinate. So that would be the 0.51 seconds. Okay, so you can see we get sort of two different things from that same vertex point. The next one, it says, when does the ball reach a height of 3? So this is sort of a backwards to a value question. We want to put in a y of 3 and figure out what the x value is. So your calculator can't do that backwards, but the only thing we can do is we can actually graph a second equation. So go to your y equals, go to y2, and just put in a y equals 3, hit graph. And what that's going to do is it's going to draw another line through the graph, something like that. So then what we're going to do is we want to figure out where do those points meet. So then on your calculator we would go second calc intersect, which is number 5 on your list. So then all you have to do is get close to that intersection point and hit enter, so we get 0.27 seconds. But if you notice from the graph, we get 0.27, which is the first one, but we also get another intersection point further over. So we've got to go second calc intersect one more time, move our cursor a little bit over, hit enter a couple of times, and that gives us 0.75 seconds. So we actually get two different answers because the ball's on its way up. When it gets to 3 meters, hits the peak, and then comes back down again. Okay, the next one, how long is the ball in the air? So we're looking for our total time, which would be our x-intercept or 0. Okay, so on our calculator, go second calc 0, hit enter, go left and right of the intersection point, and we get an x of 1.33 seconds. And that's almost it. It's asking the y-intercept. So our y-intercept is up at the top of the graph. So let me just zoom in on our graph here. We actually get a graph that does something like this. So this coordinate here is at 0, 2. So it's asking, what does that mean in the context of the question? Well, at time 0, we have a height of 2, which means that's our starting point. So the guy that's throwing the football, when he lets go of the football, it's at a height of 2 meters to start. So with these kind of graphs, what we got to be careful of is we actually don't have any negative values. So it doesn't make sense for this graph to have any negative time, and it also doesn't make sense for there to be any negative distance or height. So we actually just get a section of the graph like that. That's all we're going to be worried about. So in this case, if we were to worry about our domain and range, so normally our domain is any real number, but in this case, because we don't have negatives, our domain starts at time 0, and it goes up to what we just figured out was 1.33 seconds. So our x is between those, so we write them as greater than's in between. And we could do the same thing for range. Our range doesn't go below ground, so it'd be at 0. And our maximum height was, we answered that question in the second part, 3.28. So if they do ask you for domain and range, that's the only trick with these kind of word problems, is they're not always just going to be any real number. They're going to be usually not worrying about the negatives and so on. Okay, so that takes care of our first type. So graph the equation and then basically just solve it for whatever it's looking for using your second calc buttons, and that's it. The second type that's common is you're going to get area type questions. So you're going to be getting shapes like rectangles or whatever, and they're going to say what is the maximum area that you could get with a certain amount of perimeter. So if we look at this first example, so we've got a barn. So in this case, we just have 3 sides. We want to fence off 3 sides alongside the building, and we want to get as big an area as possible. So we know our formula for area is length times width. So that's the formula we want to graph. But if we put that in our calculator, we could get y equals x for length or w, but we can't get another variable. So we're in trouble. So what we need to do is we actually have to solve the perimeter part first, and that's why they give you the amount of perimeter material. So if we look at our formula for perimeter in this case, we'd have 2 widths and 1 length. And if we know that that's 120, we can actually solve this formula for L just by bringing the 2w over. So we'd have 120 minus 2w. So then what we want to do is substitute that into our area formula. So we'd actually get area would equal 120 minus 2w, that's our length. But then we also have our other w that we got to multiply by. So that's our equation to graph. So on your calculator, all you have to type in is 120 minus 2x times x. So do that on your calculator, and let's see what it gives us. Okay, so when you plug this in on your calculator, you're going to get your graph. So what you're going to have to do is, once again, set your window settings so you can see it. So you just have to trial and error, try to get it big enough. So you're going to need your x and y direction big enough so you can actually see the peak of the graph. Then go second calc maximum like we normally do. And go left and right of that maximum value. And then hit enter. And it gives us a maximum in this case of 30 and 1800. So the only thing you have to be careful of is what do those numbers actually mean. Remember, if we think of our 30, that's our x coordinate, which is our width. So that means we have a width of 30. And the y coordinate was our area. So our area is 1800. So the only thing we need to figure out is our length. So you can either just go 1800 divided by 30. That's easy enough to get 60. Or we could even go back to our earlier formula and put in 30 there. So 120 minus 2 times 30 would give you 60 as well. So in this case, that's our dimension. So our correct answer to the question is we should make it 30 by 60, and that would give us the biggest area possible. Okay, here's another one, very similar, except we get a whole bunch of stalls side by side. So you can see in this case we got 4 little rectangles, so let's call each of those widths the same. So we actually get 5w for our perimeter in this case. And we can either solve our length as being the one whole piece, or we could do each individual section, whichever. So we actually get 5W plus 2L equals 2,000 in this case. So once again, let's solve it for L. So we'd have 2,000 minus 5W. We can divide by 2, so we get 1,000 minus 2.5W. So that's our length. So now our area formula, length times width. So we're going to have 1,000 minus 2.5W as our length times our width, and we're good. So in our equation, you want to graph 1,000 minus 2.5x times x. So put that in on your calculator. Okay. Once again, you're going to have to set your window setting big enough. So I just put mine in, so my x goes up to 500 for my x maximum, and I've got my y maximum at like 100,000, so it's going to have to be pretty big, so you can see the graph. Now we can go second calc, maximum, and go left and right of the peak again. And we end up getting an answer of 200 for our x. Right, so if we graph this out, we get 200 for x value, and we get 100,000 for our y value. So remember, once again, our x is our width, so we have a width of 200 meters. We have an area of 100,000. So if we divide those out, 100,000 divided by 200, or we could go back to our L equation and go 1,000 minus 200 times 2.5, that's going to give us a length of 500. So in this case, if you look at our original shape here, we get 500 for the total length, by 200 would be our best shape. If we wanted to know what each size of the pen is, we would just divide it by 4, so we'd actually get 200 by 125 if we're looking at each individual size. But it doesn't matter which way you solve these, you'll get the same total dimensions. Okay, our last type of question is what I call a profit question, and it's very similar to the area ones, except in this case you're setting up your equation a little bit different. So if we look at this scenario, we've got a computer program we're going to sell for 20 bucks, and we're going to get 300 people to buy it. So if you were the store, all you'd have to do is go 200 or 20 times 300, and that would give you $6,000 in sales. But now it says if we increase it by $5, so if we get $25, we get 30 less people. So we'd have 270 people buying the item at $25. So if we multiply those, you can see we actually make more money. We get $67.50. And let's try it again. If we make $30, we actually only get 240 sales. But if we multiply those, we get more money yet. So you can see it makes sense to charge more. Even though we're selling less of them, we're actually still going to make more of a profit. So that's how we want to set up our equation. We want to get your question like this. You're basically saying we're going to go $20. So y will equal $20, and we're going to times it by 300 people. So what we want to do is figure out how many increases should we make. So in this case, it says if we increase $5, X number of times. So you can see here we had increased it once, we then increased it twice, and so on. So we want 20 times 5x. That'll equal 300. But we're going to lose 30 people, so we're going to lose 30 people for each x increment. And that's it. So that's your equation. So you want to put in, for your graph, put in 20 plus 5x for your one equation, and 300 minus 30x for your second equation. Graph that. You're going to have to probably make your window size a lot smaller. So we don't need our x to be very big. Probably up to 10 is good enough. And our maximum, you can see we're in the $6,000 to $7,000 range. So let's make it about 8,000 should be good enough. And let's try graphing that. So we get our graph. Looks something like this. So we want to get our maximum once again. So second calc maximum. You can see for most of these word problems, that's what we're solving for, is our maximum. So that makes it a little bit easier. Go left and right of the peak. And in this case, our maximum is at 3 and 73.50. So what does that mean? That means if we make 3 increases of $5, we're going to get to our maximum, and that'll give us a maximum money of $73.50. So you got to be careful. It's not that we're going to sell $3. We're going to make 3 $5 increases. So that means we're going to increase by $15. So our maximum should actually be $35. So if we sell our item for $35, we're going to make $73.50 in total revenue. So in this case, our answer should be 35. And that's it for this type of problem.